Okay, here's warm-up number 12. If possible, use the law of syllogism to make a conclusion. Okay, so if x equals 7, then y equals 9. Okay, so we know if x equals 7, that leads to y equaling 9. Here we have if y equals 9, that leads to z equaling 10. So let's think about this as a story. This would come at the beginning of my story, right? That leads to y equaling 9, which is kind of the middle of my story. That matches up over here. And the end of the story would be z equaling 10. So the beginning of the story is going to lead to the end of the story. So that means if x equals 7, then z is going to equal 10. Okay, and there is a new conclusion. I just used the law of syllogism to get that. Okay, all right, next up, let's try it again. If x equals 1, then y equals 2. All right, and if x equals 1, then z equals 3. I just circled those, but I don't know why I did that. But I'm looking for matching pieces, okay? And I do have some matching pieces. But those are both, each one of those is a hypothesis, and they lead to different conclusions. So if I'm thinking about this as a story, yeah, I know x equals 1 is the beginning of my story, but which one of these is the end of my story? I don't know which one comes first. So I can't use the law of syllogism. Your matching pieces have to be, one has to be a hypothesis, one has to be a conclusion. Here, the matching pieces are, each one's a hypothesis. So that doesn't work here. This is going to be not possible. Okay, so a lot of times I'll see people will say, if y equals 2, then z equals 3. But I don't know if y equals 2 would come before z equaling 3 or vice versa. Or maybe they happen at the same time. I just can't use the law of syllogism there. It doesn't work like that. Okay? All right, here we've got a conditional. So this is my hypothesis. This is my conclusion. I'm just using lowercase p and lowercase q for that. So if this is my original my original conditional. I lost the word for a second. The converse, I just switch the order. I flip it around. So I'm going to flip this. Okay, I'm going to say if b equals 4, then a equals 3. Okay, and there we go. There's the converse. Okay, the inverse is, I'm going to leave things in the same order, but I'm going to negate them. So the negation of my original hypothesis, the negation of p leads to the negation of my original conclusion. So I'm going to leave these in the same order, but I'm going to negate them. Okay, now the negation of a equaling 3 would just be a does not equal 3. You could write that out in words, but much quicker way to do it is like that, right? If a doesn't equal 3, that's what this means. So a could equal anything except for 3. And then the negation of this is b doesn't equal 4. There is my inverse, okay? All right, so converse, I switched the order. On the inverse, I negated both parts, but I left them in the same order. Contrapositive, I'm going to switch the order and negate both parts. So the negation of my original conclusion is going to lead to the negation of my original hypothesis. Okay, so I'm going to put the b equals 4 part out front, but I'm going to negate it. So I'm going to say if b doesn't equal 4, then a doesn't equal 3. Switch the order of both parts and negated both of them. All right, and there we go. See you next time.